So in this part, we will look at one of the most important but underrated SON feature called ICIC or Intercell Interference Coordination. The way the radio waves propagate, mutual interference nearly always occurs between the cells in an LTE network. If interference is not managed, then it can lead to signal quality degradation. As you can see in the picture here, we can say that there is little or no interference in the regions shown as darker shades of blue. The lighter shade shows interference. As we have discussed, the different base stations, or in case of 4G, the E node Bs, can talk to each other via the X2 interface. They can coordinate to remove the interference. So as you can see now, after the base stations have coordinated over the X2, the interference has now been reduced or removed. So the goal of intercell interference coordination or ICIC is to ensure there is no interference in overlapping areas between the cells. Now each particular vendor implements their own proprietary algorithm to reduce this interference between the cells. So some basic algorithms have been defined and discussed in various literature. So we will discuss some of them here. Hard frequency reuse or HFR is the way GSM used to work. So each cell will only transmit on limited resource blocks. So there is no chance of interference. Frankly, this is a very bad approach as this is underutilizing the spectrum, which is actually very expensive and precious. So nobody in practice would ever use such an approach, but this is just to give you an idea. This is in literature the most popular and basic approach, right? So all vendors implement an advanced version of this, which is generally proprietary and the secret sauce that differentiates the vendors. This consists of dividing the spectrum into two parts, which will have different frequency reuse. So one section of the system spectrum is used in all cells, while the other part of the spectrum is divided amongst different E node Bs as in hard frequency reuse. So the idea is that the E node B would assign the fully reused frequency chunks in the center cell UEs and the other chunks in the edge cell UEs or cell edge UEs. This scheme is particularly useful for ICIC in the uplink, where severe interference situations can occur, where the user is located close to a stronger interferer in the neighboring cell. In the example shown on the top, half the frequency band is reserved for nearby mobiles, while the remainder is divided into three sets, the F1, F2 and F3, which is used by distant mobiles. The resulting reuse factor is 67 or 67%. In case of soft frequency reuse or SFR frequency partitioning method, an E node B transmits in the whole system bandwidth, but by using a non-uniform power spectrum. So the picture shows assignments in the different cells of system using the soft frequency reuse and a reuse of 3. So it can be noticed that in the spectrum there is a region of high power transmissions shown with the dark blue color and some regions of low power transmissions shown in the light blue color. Using a similar strategy as previously discussed, resources in the high power region are preferably assigned to UEs located at the cell edge, while the cell center UEs are typically assigned resources in the low power regions. So in LTE, E node Bs exchange the load information messages over the X2 using the X2 application procedure messages. The purpose of load indication procedure is to transfer load and interference coordination information between the E node Bs controlling intra-frequency neighbor cells. So in the message, E node B can include three information elements for each cell that is controlling. The first describes the transmitted power in every downlink resource block. The neighbor can then use this information in its scheduling procedure. So by avoiding the downlink transmissions to distant mobiles in resource blocks that are subject to high levels of downlink interference. The second information element describes the interference that the base station is receiving in every uplink resource block. So the neighbor can use this in the similar way so that it does not schedule uplink transmissions for distant mobiles in resource block that is subject to high uplink interference. The third is the list of uplink resource blocks in which the base station intends to schedule distant mobiles. Here, the second base station is expected to avoid scheduling uplink transmissions from distant mobile in those resource blocks so that it does not return high levels of uplink interference to the first. So let's look at the load information contents. Upon receiving the high interference indicator or HII, the neighboring cells may wish to avoid scheduling on the indicated resource blocks. A cell receiving the overload indicator or OI may reduce the interference generated on some of the indicated resource blocks. For each resource block, the relative narrow transmit power or RNTP indicates whether the transmission power of the resource block is greater than a certain threshold. Upon receiving this information, a neighboring cell may avoid scheduling on the resource blocks indicated as having a high power transmission. So ICIC defined in 3GPP release 8 and 9 was defined with a homogeneous macro cell deployments in mind. It provides only relatively simple means for ICIC and fails, for instance, to address mechanisms to improve intercell interference on control channels. So that is, you can say the PDCCH, the PHICH and the PCFICH. So this limits, for example, the aggressiveness in which the range expansion can be configured and hence the gains that can be achieved using het nets with the cell range expansion. So some of these limitations were addressed as part of enhanced ICIC or EICIC, which came as part of 3GPP release 10. There were even further enhancements that came later and are referred to as the further enhanced ICIC, so FEICIC. We will look at them in another video in future. So some references here if you are keen to study this particular topic further. Slides are on the SlideShare channel and it will come on the 3G 4G website as well in maybe a few weeks or a few months. So hopefully this quick introduction of ICIC was useful. I wanted to explain this before jumping into the next topic of mobility load balancing or MLB, even though they are not directly related. In the meantime, please keep safe and see you again soon. Thanks and goodbye.